Repeat it.
One more time. Does it sound new to you? They tell you that the distance is the area of the speed graph. They actually tell you that. Oi, I'm just reading the graph. Okay, now
No, I know what you're
I'm
saying,
very
but I'm
confused.
saying like, how does that work? How does it help?
Oh my goodness. Okay, now I'm worried. Now I'm glad that
No,
we're talking
because how are
about
you
it.
supposed to know without knowing what?
Look,
Calculate.
the area has a shape, right? Tell me what's the shape?
Fraudulent. I forget. It's not.
Come on, trapezium. It's a trapezium,
I forget the
right?
term. I forgot the specific term.
Trapezium.
Yeah.
Okay, this is a trapezium. Do you know what's the area of a trapezium? As in the formula lah.
Yeah. The formula.
You don't.
Yeah, I know.
What's the area of the trapezium formula? Okay, go ahead.
It's a triangle plus the rectangle plus a triangle.
You know what? You're correct. Now I'll give you that. You are correct. So the two triangles plus the rectangle will be equal to 450. Right? Now let's acknowledge that you do not know the height of the triangles and the rectangles. True? You don't know
Just
that.
be half times 10 times v plus 20
Okay,
times v.
Then do that, then do that and equals to 450. Then you will find the v, right? If that makes sense.
Oh. To make it easier for me, I'll just do that 5v plus 20v. Wait, teacher. What do you say the answer was again?
Yeah. Ten something, 12 something, I don't know, 12 something, I guess.
What do you mean 12 something?
Hey, bro, you haven't used the 450. This is the area of the trapezium. You are absolutely correct. Granted. Now this is equal to 450. Make sense or not? If this doesn't make sense, you gotta tell me.
It makes sense.
Okay, then this equals to 450. Then you get the V.
This equals to 450. So like 37.5 over 40, 450.
Equals to V. Yes.
So that's the speed.
Press your calculator and get something.
Wait, it's 37.5 over 450, right?
Hey, I mean, just equate that to 450 and do your math, please. At this point, I'm very confused already.
What do you mean equate what to 450?
Oh my bloody goodness, right?
I
am worried. I'm very worried right now. I'm very worried. I think we left math for too long. Yes. Thank you. Yes. Maybe we should go back to math. Maybe. Yeah. Now I'm confused. Now I'm worried.
Because like That would be, remember correctly, if you do this
Okay.
right, technically it'll be m over s squared.
No. M over S times S. Wrong. It's M.
No, 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 as in,
M over S times S,
yeah, which
which is
technically,
M, which is meter, which is, distance, which makes a lot of sense. The unit makes sense. When you do the gradient, you will get the meter over second square acceleration. The unit also makes sense.
wait. When you say, no, because look at it. Look at deceleration is 1.4 m over s squared in the previous question. I mean, it's a different thing, but like, can you
Um,
tell me when does this happen? Hello,
acceleration, that's not distance. Here, can you hear me? Is the connection okay?
I can hear you now.
Okay, all right. Okay. Uh, Nicholas, are you confused about the distance? Is that why you're asking all these things?
No, I'm just trying to make sure because like, mm, I want to know when does when does this meter second square world thing happen? How do you know what is it?
Yeah, it's a gradient. Gradient is not area, right? Gradient is what do you call it? The rise over the run. When you rise over run, you're dividing, right? Your area is not a division. Your area is a times.
So it's just okay. I get it.
Mhm, mhm. It is true that both gradient and area requires
Oh, no wonder
rise and
it's
run.
second square because it's a divide. Yeah, it's a divide.
Yeah, it's a divide. One is a time, one is a divide. So no surprises there. But it
Calculate
is
the
true that
meter
it can be
speed.
confusing. Hey,
So A is just 12.
done. All right.
Calculate the acceleration for the first and second spin. Acceleration, just gradient, right? Yeah, but it's a V in there. Ah, wait, no, V is just 12. No, man. Yeah, V is just 12. Yeah, no, man. Yeah, yeah. And Y on top, X on top. So it should be, so this is 0, 0. Then the Y on top is 12. And the X in the bottom is 10.
Mm-hmm.
So
Mm-hmm.
that's just negative 12 over negative 10. It's just 1.2. Wait, since this is acceleration, this 1.2 meters second square.
Yep. You do need to write down the unit, correct? Hey,
Like
you're
that.
this. Yeah. Okay. Yeah. You're saying. Yeah. Yeah. Correct. Correct. That's correct.
Then calculate, use the graph, the grid below, sketch the distance. Right. Mm, I don't know how this works.
Your page is half inside, half outside. Thank you. Oh, you didn't. Okay, sorry. I thought you write something on the left hand side. Okay, good. So I mean, A and B, simple enough. Good, great. They now want you to sketch the distance time graph from the speed time graph. Definitely a challenge. Definitely. Can you do it? This is considered the hardest thing they can ask you. This is considered. Can you do it? I'm very glad that you asked this question. I'm very glad.
The speed increases, so the distance. I don't know how. Only thing I can
now
see is like logic or something.
you should use a lot of logic here. There is almost no formula here that helps you. It is
Because like
most of the time
it's
logic.
obvious that since it's accelerating, the the distance to the time should get shorter, shorter. But then this one is the same, so it should just be the same. Like
Use pencil first lah. Use pencil first. Use pencil first. Okay. This is the hardest, so
I should just like I'm
let's
going to
see.
draw. I don't understand how this works. I don't know how you form bird.
You try for 5 minutes and then I will explain. All right.
Let me try
Definitely the
5 minutes.
hardest.
Apparently I can read. Here's my eraser. My eraser is gone. It's great. I gave high my eraser is gone. Let me get another eraser real quick. What's my eraser? Let me get an eraser for my room. Uh, Gave my reason to my friend. I forgot to check that. Yeah, I forgot to check that. So we definitely need friends. My friends are not. We definitely need friends.
Blue color pens?
I have like one working pen and 5 pencil paper. I just haven't taken out the rest. I forget which one is like why. Sorry, teacher, for keeping you waiting. Very much sorry. Also, teacher.
You
Teacher.
say? So, can or not?
So the logic that I have is that you see this acceleration, so it gets faster, so it covers more distance in
Mm-hmm.
less time.
That's
Mm.
fine.
So technically it should go up. The numbers I don't care, I'm just doing randomly.
Sure, no problem.
Okay.
As long as you
And
do
this
pencil,
is
that's fine.
then this is the same speed.
Oh, wait. First thing first, start from 0. Come on. Start from 0. At 0 time, the distance is still 0. If that makes sense. So you should start at 0, like whatever you draw.
So
Okay, something like that. Good.
wait, wait, speed that increases. Whatever like that. It should probably be like a curved graph because the speed that I don't know explain.
I like the curve. I'm okay. I don't see the curve, but you say curve, I believe. All right, then.
Yeah, I no. I know there should be a curve because like wait, let me think. Covers more distance. It starts to it gains speed, so it starts to cover more distance in less time. So like try like that. Wait, no. If it covers more distance, it should be like that. Yeah. Because then lesser time it covers more distance.
Okay.
That's all.
Okay.
We got many mixed friends. So why did I pick those mixed friends? No. Later lang, we find it. We find it.
It's not bad. It's a highlight. Okay, so then that is the same speed. So the distance just has to increase.
Okay.
Wait, when the distance decreases, how does that work?
First thing first, the distance did not decrease. The speed decreased.
It's just distance. Oh,
The distance is the area. The area is still there, so the distance did not decrease. The area is still there.
No, I was
speed does
looking at a
decrease.
different graph. This one, but then I realized it's like those
Correct.
m/s,
That's a distance graph.
not like this one,
Correct.
which is
Correct.
m/s
Totally
squared.
different. Yeah.
So
Absolutely. Totally different.
if this thing goes down, that will mean that it gets slower. If it it covers this distance in 10 seconds. It's at rest. Then this one it slowly slows down. So at 35 seconds it covers 0 distance. And here
But you shouldn't talk about this graph too much, right? You should talk about the graph that we're talking about.
I
Right?
really don't understand. Like how do you explain like this part, the constant part?
Okay. I gotta explain, okay? I gotta explain now, okay? Gotta explain now. We're taking too long already, yeah? Now, please watch the Jamboard. Now, this triangle, I'm gonna make it bigger, sorry. I'm gonna break down to 450, right? This one is, I believe, 240, right? 240, how do I know? Because this is 12, 12 times 20. 12 times 20 is 240, okay? 240 meter. The rest of the triangle, this one will be half times 12 times 25, which is, I believe, 150 meter, right? And then the first triangle will be half times 10 times 12, which is equal to 60 meter, for a total of 450. 240 and 150. Okay? Okay, clear, yeah? Okay, now for the graph, I'm ready to move into the graph, right? I'm observing 10 and 10, and then 30 and 30, and then 55 and 55. There's my 55. I observe all these numbers. The second number I observe is 60. 60 is here. There you go, my 60. And then 240. Where's 240? Is here, 300. Yeah, see, plus 240. There you go. And then last one, 150 is here, 450. 450 plus 150. I have observed all these numbers, then I start to draw. Do you understand what I'm saying so far?
Okay.
Okay. Now, the easiest point is this. At 0, it is 0. So that's my point. By the way, professionals go by points, okay? I don't care about the curve or the graph yet. No curves,
Wait.
no graphs, no lines.
I understand
point.
when you say
Mhm.
200, like 300 to 450. That's like, this 150 over here.
Yeah.
I think. But then where do you get it? But where is this 240?
I'm not seeing anything though.
No? Okay, wait, can you do
Nick
this?
is 60 plus 240 plus 150 equals to total 450. Okay.
That's not. How does 150 plus 150? That's 300. 300 plus 240 is 500.
Yeah, Nick, I'm very worried about your math right now. Okay, 60 plus 240 plus 150.
60. Oh, wait, oh yeah, that's 60. I read this very much as 150. I don't know why.
Okay, no. So it's 60, right?
Yeah, no, I get it now. I was very confused. So like, yeah, okay, 60.
Okay.
Then plus 240, then plus 150. Yeah, I get it now.
Okay. So do you want me to draw the graph or not? I mean, we are not done, but we are very close lah.
I don't need. I get
Okay.
it.
Okay, let's see how you draw the graph then.
I should write this one.
It is true that you should. Yes, it is true.
So 60 is the distance. So and then it's in 10 seconds. So just here. And then it's just in 30 seconds, it's 240. It's 240. It's plus 240. Then it's plus 450. Plus 150. 300 plus 150 is 450. Should be fine.
What you're doing is great. I like what you're doing right now. Yeah, I like what you're doing. The points
Wait, by
are
the way,
great.
if it keeps going up, right? Then how does this power work? How does this one work? Can you tell me like what this
Brother,
one?
why are you comparing question 1 with this question? Why?
No, I'm just
Why
like,
do you compare different graphs? Why?
No, I'm not comparing.
Why do you
a
go
graph. I'm
back
not
to
comparing
that
a graph. I'm just trying to find out what the name of it is.
Brother, can we finish this one first, then we compare? You're already comparing. You're asking me, how does that guy work? That's a distance graph work. This is a speed graph work. Can we not bring in the distance graph until we finish drawing it? Because what you're drawing is still wrong, you see.
What speaker?
Yes.
Huh? Okay, there.
The curve is fine. Like I like the last curve. The first curve, the first one, the one from 0 to 60. That part is also a curve. Can you show me what the curve looks like?
Kasih nasi dikit ya.
Yeah, it's gonna be a curve. It's gonna be a curve. It's a small curve, but still a curve.
Like that.
Nice, nice. The way you draw it is excellent. No, you are excellent here. You're excellent here. This is great. Love it. Okay, now this is correct. Before I answer your question, can you answer this question first? Are you sure you can answer this next time?
I understand now.
Okay. Now, you are going to compare this distance graph with the previous distance graph, not the speed one, the distance with distance graph. Okay. First thing first lah. Now, what's your problem? Why is this distance graph so different from the other distance graph? Is that the problem?
No, yeah, I just don't know why the other distant graphs like it goes down.
Because the question says so. Put it this way, this guy is moving forward. That distance graph, which is reducing, that guy is moving backward. So to speak lah. So to speak. And that's possible, right? We can move forward and move backward. So to speak lah, we can. It is possible. In fact, you should have asked, hey, the other distance graph, how come it's constant? Well, he's not moving.
And I know that one. That one's obvious.
Correct, lo? So you can not move, distance constant. You can move forward, distance increase. You can move backward, distance decrease. Ta-da! If that makes some sense. In fact, the distance graph, the previous distance graph was a bit weird lah. People don't usually want to talk about moving backward, usually, I suppose. But it's possible. This distance graph is more normal. People usually talk about moving forward, I guess. Yeah, again, negative distance are usually not a thing, usually. That's the weird part. Now, have we answered your question?
Yeah, so it's that simple. Okay.
And you should ignore the first one. The first one is very rare. Again, people don't usually talk about reducing distance. Usually not, I guess. Not all the time, I guess.
Okay, another next one. Oh. Okay, at least they drew the units for me. I just have to draw the graph. It's fine. It's fine. Okay, wait. I can just screenshot this. Actually, it's not that bad. I'm gonna screenshot it for my convenience. For the graph, because I do not want to just go look back and forth.
Do you have a graph paper? We cannot do it
The
without
graph
a
is at the
graph
back.
paper.
The graph's at the back.
Oh,
They drew the
yeah,
units for me already.
yeah.
But like,
You're right.
I have to
You
draw the
should
actual graph
should
myself.
screenshot it. Yeah.
See,
Yeah,
look,
you should screenshot it.
I
It is very
don't want
annoying
to have to go
mistake.
back, so I have screenshot.
Correct. You're right.
At least they drew the units for me, so that's fine.
That's easier. Yeah. That makes it easier. That's a lot of headache at first.
T0, T0, H75, T0, H75. T1, H85, T3, T2, H85, which means the maximum point should just be in between right here, T75, T3, H75. The maximum point is very obvious. T4, H55. T5, H25. And okay, T5, H20, T5, 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 H25. And I forgot to do the P. $75 plus 15, 6 minus 5, 6 squared minus 15. So it's T6, H negative 15. But let me redo the screenshots I can. Okay, T6, T. Okay, wait. T, wait, T, 6, 6, H, negative 15. T, wait, T, C, 6, T6, H, negative 15, negative 15, yeah. Now, on the grid, draw. So, that's the sea level. So, 0 is just, it's like the very, it's a 0 is just before it goes to 0. So, anything below 0 is just a Z, the C. I think above, it's there. Maximum height of the stone above sea level. Oh, it's these kind of questions. Okay. Uh,
Your drawing skills are good, isn't it, Nicola? Wow. It is. It looks very nice here.
there is one slight off. I feel about this. There we go. So now, let me maximum height of the stone above sea level. Well, that's easy.
You got there. Yep. Because of your drawing seems reliable. I like it.
Honestly, it's in between, and that really annoys me. So I'm just gonna like contort it, change it a little bit.
Not too much, please. Too much.
I'll just make it into like 85 or something, 82, 87.
You know what? You can get an exact answer, you know. Do you want?
How? What, make it into
Find the time.
86?
Find the time. Where's the time?
You have
If
to
you
find the
contort it too much, you may get the wrong answer. What's the time there? Come on,
time,
what's the time? Yeah,
1.5.
right. Good. Now put it in your calculator.
Oh, wait, yeah.
1.5. Yeah, you should do that instead of contorting the graph. Okay, it may lead you to wrong places.
It is 86.25. So actually, my original one was actually very.
And you should follow that. You should follow that.
Now I need to go back to my original. There you go. Okay, there. That is technically 86.20. That's definitely 86.25. Use a graph to estimate the maximum height. But they want it to 1 dp. So I'm gonna do 86.3.
Fair enough, I guess. Fair
No,
enough.
86.2.
It is
looks
true that 1 dp is the most you can. True enough.
wait, do I do once? I'll just write like an X here and I'll say 86 point wait. I'll write an X there. I'll do T 1.5, then H is 86.3. Yeah. So then the answer will be this one will be 86.3. The maximum height. Okay, height it is 86.3. 1.5x 1.5x 86.31. Then the length of time that the stone was more than 80 meters above sea level. Well, more than 80. Well, according to my graph, it's around 1 and 2.5. Let me just see get the exact one. I mean 0.5. 0.5 is 81. Wow, I'm actually that was very accurate. That's actually not that. That's not accurate. Never mind. 0.1. 0.5 is supposed to be 81.25, which means this graph is supposed to be bigger like that. But that'll be that's actually way better. Huh. Okay. No, that's 81.525. I'm so OCD.
I guess.
Okay, that's a perfect. That's perfect. Uh, there you go. Yeah, it's fine. It's fine. Okay, so it's around 0.45. And that is very accurate, actually. 0.45. I should say that. Length of time. All right. I'll say like 0.45. I'll try that down real quick. And then over
Okay.
here, this is, let me, okay, I got the point already. So let me, two point six. Let's see how accurate it is. It is very accurate. 2.6 is very accurate.
Very good.
And 0.45 is so very accurate. So like, you know, it's nice. 2.6 minus, wait, 2, 2.6 minus 0.45 is 2.15. That is the length of time. That's above. And the time taken for the stone to hit the water. So that's, that was an actually obvious answer. That was 5.7, 5.5, 5.6, 5.7, 5.7. Now let's see how, as again, very accurate. Let's see how it's accurate.
Mm-hmm.
75 plus 15, 5.7 minus 5, 5.7 squared. Well, that wasn't as accurate, but it's fine.
Mm-hmm.
It's like this negative point something. By drawing a tangent, find the gradient of the curve at 525. When you say find a gradient, right, you just have to make make a line at the tangent, and you can just make any two coordinates. It has to be a tangent, right?
First you gotta draw the tangent first, and that's where your skill comes in. You draw it wrongly, then the tangent, like really, really wrong, look. Really, really wrong.
Okay, well, I know where it is.
Where's your
Here.
525? Yeah. So the position is not the
Wait.
skill. The skill is how you use your ruler. Let me see. Use pencil, please. Yeah.
Yeah, wait. T, wait. T, T, 5, 5, H, H, 25, 25. Okay. So it's, yeah, obviously there.
Okay, your ruler. Yeah. Let me see your ruler.
So you want me to find a tangent? I'm just gonna put my point there. And then I
Let me
explore.
see your tangent. Let me see your tangent. After you draw the tangent line, let me see it.
Well, that's
Okay.
actually hard. It's because of, okay, I'll try
Yeah,
to
it
make
is.
this
It
two.
depends on your skill.
There you go. It's because this,
Why would you do that?
it's because this specific curve, right? I already knew it was like inaccurate.
A bit
Like it
off.
was
Yep.
like a
Yep.
bit bump, like a big.
Correct. 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 That's why this depends on your skill. That's why.
Oh my god.
Now
That's the
let's see how
worst.
much you can do it.
Okay, let me connect this. And I just go like that. And then I go like that. Like go like that. And then I just connect it like that. Yeah, that's should be good enough. Right? It doesn't seem curvy enough, but it's fine, I don't really care. Arms are drop. Tangent. Way easier now. Uh Tangent. Actually, wait, let me take my long ruler. Let me get my actual ruler. Like the longer one. The 15 centimeters.
Mm-hmm.
This is the only way I can think of a line. Just like this. Like that. Very good.
Sorry, my video is lagging a bit. I'm still waiting for the video to crash me. Yeah.
You see it?
All right. The graph itself looks great, and your tangent line kind of looks great. Now, I'm going to use a cheat code, okay? Okay, Nicholas, I'm going to tell you how an A-math student can get the exact answer. This is an E-math. I'm going to tell you the A-math way so that you can adjust your answer. Would that be okay? You understand what I'm saying?
Yeah.
Okay. Now, here's the A-math way of doing it. This method will be available to you Sec 4, meaning at O level, it will be available to you. It is not a difficult method at all. It's just that it doesn't make sense to you right now. I'm going to show you, yeah? Show you that first. So by this A-math method, you can generate the exact answer. The gradient of H will be, instead of, this is 75 plus 15t, right? This is H minus 5t squared. Now you're going to see me do something that doesn't make sense, okay? This will become 0, this will become 15, and this will become minus 10t. Yeah, minus 10t. So the gradient of H will depend on this particular function, which I do derive from the H function. You have not seen this method in A-math, you will see this in Sec 4. Okay, so wait.
How does 75 becomes 0?
This is called a differentiation. Again, the method that you will learn in Sec 4. And how does that become 0? How does 15t becomes t? How does minus 5t squared becomes minus 10t? You gotta believe me for a while. I'm not teaching you this, I'm just showing you. However, I guarantee you, you will use this as an A-math student in Sec 4. Now, I'm going to put in t equals to 5. And then suddenly, you have the gradient. You have the gradient 0 plus 15 minus 10 times 5, which is going to be minus 35. Wow, the gradient is so bad. Wow. Okay, the gradient that you're supposed to get is, yeah, I know. Again, I'm saying I'm not teaching you, I'm not making you understand. I'm telling you that the gradient should be minus 35.
Okay, let's see.
So let's see whether
it.
your line will get minus 35. If you get it around there, then you're happy, no?
Okay, wait. So it's y first. So it's,
yeah, price
this
over.
Is 60. I'll do the first part. So this is 60. Then this one the t is, wait, this is 4. This 3.9. 4 3.9, and then the top part here, this is 0, and this is the 5.5, 5.6, 5.5, wait, 5.5, 5.6, 5.7, 5.8, 31. Huh? Okay, so I got 31. So I am very, very accurate. I got negative 31.
Negative 31, no. I guarantee you first. Negative 31 is considered very close to negative 35. Why? It is a 10% difference, almost 10% difference. I mean, you go a bit beyond 10%, just a little bit only. You are not inaccurate. Believe me, negative 31 and negative 35 is very close, very, very close.
Well,
So anyway, you only have to change your answer a little bit only. You need to get negative 35. Now, let me ask you, negative 35 is more slanted or less slanted than your graph?
more.
More or less? Then just slant your line a little bit only.
I
So
can't
very much
because
little.
if I slant my line, it'll go on another part of the
When I
gradient.
say very little, I mean like tiny itsy bitsy, just a little bit only, just to
And
shift it closer to negative 35. Just a little bit only. I don't mean 1 million, just a slight difference. Slight difference only.
okay, wait.
Just a little
Ah.
bit. Just a little bit. This means you're good. You're good already. Just make it nicer. That's all. That's all.
Oh wait, huh? Wait. I just realized something. SCX. Okay, wait. SCX. Why when I make it, if I want to make my I need to make the gradient. I need to make the gradient bigger. Like to make the line like more like that, right?
Yeah, a little
Okay.
bit only. A little bit only.
I literally can wait, let me see if I do it here. So I make it 4. That's negative 33. Oh my days.
Negative 33 is better than negative 31, right? Okay. We'll accept that. We'll accept negative 33.
There we go. Why did hey! Oh my pen, like I need to sharpen my pen. It has gotten a little. Oh. Oh, I don't like this. It's too sharp. Okay, I've got the thing again. I should make it a 4 like that. I can't make it 4.
A little bit is fine. A little bit
No,
is
I
fine.
literally cannot. If I try to make it a little bit, right, you already crossed the graph. Like the previous one is like already really touching. Unless I do something here.
Just a little bit. Just a little bit.
I have to do something here without getting rid of the it's a bomb. Okay, let's see if this could work now. Minus 5.7. Where's the 5.7? Actually, no. Okay, let me see if I can. I just need to make this a little. Let's see if I can, let's see if I do this. What happens? Like that. Okay. This could work because it doesn't technically is it cross.
Oi, you should be ending this soon. Alamak, we're taking too long already.
I cannot. No, I
We're
literally
taking too
cannot
long already.
do it.
You say that you can get negative 33. Again, tell me what's the problem?
No, I can no. Negative 33 is if like I make the curve like the line technically not a line because like it'll go over no matter what happens, right? The line I cannot make it negative 33.
So
I
you're
just
saying
make
that negative 31 is your best. You cannot go anymore.
let me
That's
wait,
what I'm
okay,
saying.
wait. No. Let me do something else. Let me just give me some
Okay.
time.
Yeah. You don't have to get negative 35. Just a little bit better only.
Okay, let me do something. Okay. I have another thing. This is 60 on wait 4 and the y is negative 1 with the x being 6. Negative 30.5. Can do that. Now I'm aging it up very hard. Now this look at that. That's still 60, but the x is now 3.9.
Less, maybe.
Oi,
Okay.
60, but the x is now 3.9. And then this y is still no, this y is now negative 6. And then it's still the x is still 6. Negative 31.4. There is no way I can make it bigger. Let's do that. Like a really oddly specific unit. So that is this one is here and 4. That is 4.2. That is x is 4.2. Y is 50. Then this one is y is negative 10. And the x is 6. Negative 33.3.
33.3 is excellent compared to 35. Excellent. Really good.
I messed it up. I messed.
Promise to teach you the AMAT method, so that you get a better answer, right? Promise to teach you when the time comes. It'll be useful for you in prelim and in O-level.
Okay, let me just make sure that I actually did. Okay, this is 4.2. Yeah, definitely. This is also, it's not 50. It's not 50. Wait, that is 53. Hey, negative 35. I got exactly
35,
negative.
really?
I got exactly negative.
Really? Without doing weird stuff?
No.
Wow, without doing weird stuff, eh? Nice.
I made it
Good.
go from, okay, so this is
Good.
X 4.2 and that's Y 53. And this is X6 Y negative 3. And that is exactly negative 35.
Nice.
I'm definitely taking
Very nice.
that. That's way better than negative 33.3. Say the units of my, okay, let me state, like, wait. This is X is 4.2, Y is 53. Wait, T is
Already, sayang. See, already.
4.2, Y 53.
I already checked with you.
Yeah. Then this one, X is 6, Y, wait,
I already did this.
X is 6, Y is negative 10. There you go. So that is way better. 4.2, 53, 6, negative. Okay, wait. 4.2, 4.2, 53, 53, 6, 6, negative, negative. Okay, teacher. Oh yeah, it's like 22 minutes. Okay, so we
Right,
finished.
Good. That would be your answer. Good.
Yeah. Because if they have that,
Well, I mean, at least we covered the harder questions, so I guess I'm okay. It took a bit too long, but I'm happy with your results. Very happy. Do you want to talk about the chemistry a bit? We have 7 more minutes.
Okay, like actually, what have it? How about how do you remember like the
I know. I already tried my best, huh? Yeah, okay.
I don't know what to do. Some minutes is not enough time to cover
Yeah.
anything.
Mm-hmm.
Really, it's not enough time.
I mean, you can get one of the papers and then immediately just answer one question. I mean, just
Okay
whack the
lah.
hardest one, right? That works.
I see. I'll see a chemistry. Yeah, term 2, 2023. I'll do like one. They do this kind of question. They steels and L. Okay, I can make it. Wait, malleable and ductile is like. Wait, malleable means that you can like reform the metal, right?
I guess that makes sense.
Like when you hit it by huge force, then it's like changes shape.
It will, something like that. You're right. You'll then
And then what's
basically
ductile? I forget.
you
Oh,
can
able
pull
to.
it and you'll get longer.
Oh,
Pull it and get longer. Like that, like malleable is
that's
when
easy
you
one
hit.
because the elements are of different sizes, so like the regular shape is not there. So you
Don't say
got
elements. Don't say elements. The alloying element, the carbon. Just say sorry. Just say carbon atom of a different size than the iron atoms. Just say that, and you are correct already.
the carbon and
Then you say they are
iron.
harder to slide
Wait, did I
against
say
each
the
other. They're
carbon and
looking
iron
for that phrase lah.
atoms? Or like, what did I say? What?
Are different sizes. Yeah, carbon and iron atoms are of different sizes. That's
Carbon
fine.
iron
That's totally fine.
atoms are
Of different sizes,
diff-
so they have difficulty sliding
Oh my
against
days.
each other.
I just realized this is chapter 2. Wait, metal on.
I get.
Wait. It's not. Never mind. Never mind. I don't believe chapter 2. Chapter 2 is not this. Never mind. No. Chapter 2 is definitely not this. Even if it is, it's fine. Are of different sizes. So wait, how do I say they like regular shape is not there anymore? How to say?
Sorry, you're saying? Sorry, I'm saying.
How do you say the regular shape is not there anymore?
The regular shape is not there.
No, because there are different
Sorry.
sizes, right? Like if it's just iron
Yeah.
atoms, there'll be like a
No,
regular
you don't mention
orderly
that.
arrangement.
You don't need to mention that. What you need to say is the sliding paths. Because malleable and ductility is about sliding
So
past
wait,
each other.
so it will be harder for the atoms to
For-
slide past each other.
Past each other. That's it. That's what they're looking for. Done. Really done.
Wait, I'll say for D, not for atoms. Okay, I have enough for one more. Sodium hydroxide solution. This makes it a solution iron 3. What's nitrate? Is it NH minus? Wait, no, I'm right.
Are you saying? Sorry, what?
Wait, no, no, I got a definitely wrong. Okay, NO3 is nitrite. NO3 minus is nitrate. Plus is an N. NO3 minus. And iron is Fe3 plus because it's 3. Wait. NO3 minus, right? Yeah, NO3 minus. And then sodium hydroxides. Hydroxide is OH minus.
Mm-hmm.
And sodium is what? What group is it in? How much?
1.
Wait, sodium is what else? What? Any 2 minus. Wait, huh?
Wait, 1. Group 1. Oi.
No. I was thinking of something else, my bad. I was thinking of like what? NH something. Okay. So any minus. Right. Any plus.
Ayo, plus. E.
Sorry, I'm rushing. It's 1 minute.
True enough.
So it's iron 3 hydroxyl. Iron 3 hydroxide. So it should be 3. And a color solution of sodium nitrite. Well, that's annoying. Okay, wait. So Fe3 plus. So the hydroxide has to be 3. So any plus OH minus has to be 3 in order for this to be 3 OH minus. Now say that Fe3 plus OH. However, that will mean that will be 3 Ne plus. There'll be 3. There'll be 3 of Ne, which means the plus cannot work. So you need 3 of this for that to work. But then there's also 3 of this. Wait, there's a very easy way to solve this. So if I can just let me so it's simply hydroxide needs 3. So it should be FeOH squared, OH bracket 3. But that would mean that the Ne also has a 3. But the NO3 is
Right. Nick, I cannot follow, yeah? Okay. Keston, I can hear you. I can see you. Can you hear me?
I don't understand. I don't know how it's supposed to.
Yeah.
Keston, I can see you. Can you hear? I cannot follow Nicholas. I was actually confused what you're doing. I cannot follow your paper.
Oh my days.
I got it. Okay, good. Okay. Because the connection is very bad. Connection is very bad. The video is very bad. Sodium hydroxide solution is. Sorry, the video is very bad. I cannot read. Yeah. Could you just screenshot for me and then I'll answer it through Jamboard because time is up anyway, right? Oh, there you go, much better, right? Mix a solution of so yeah, it's getting worse. It's just getting worse, right? It's just getting worse.
Please read it.
Yeah, could you screenshot for me? Just screenshot for me. I'll write down the answer for you. Right? Come, quickly.
Okay.
Aston, can you hear me?
Yeah.
All right, Aston, I can hear you. So updates, please.
Nothing.
Got it. What's the news on exam?
Like on Thursday.
Thursday. We're talking about this Thursday, and you already know the topics, yeah? Nothing changes, lah. Correct? Okay, Nicholas, I promise to answer to you in 5 minutes. All right. Okay, you just see the Jamboard and you'll see the answer. All right.
Okay. Bye.
Hey, Nicholas, I'll see you on Wednesday. Bye. Let me see. You were doing, oh, you're doing practical. Yeah, you're doing practical. Do you still need to do the practical practices, lah, I guess, today? But my connection is so bad today, isn't it? Wait. I can't hear you very well. Wait. It's. Oh. Do you have practice paper from school, exam coming, or do we need to do Google Drive, or do you want to continue with the practicals? What do you want to do?
I have practice paper from school.
Shall we do that then? Right. I'm curious, always curious about SST standard, right? Okay. SST standard a bit higher than the rest, so I'm very happy we can do that today. Jamboard is almost full. If you have a lot of questions, maybe you want to just make a new one. Tell me if you do it. Okay, good. I'm seeing some questions. They are not very difficult, huh? Oh, the first one not so bad. The first one is quite challenging. First one quite. 13 is quite okay. Yeah, we should practice the 16. Not very difficult. Okay. Yeah. Good questions. Good questions. Keston, do you want to do it, or do you want me to discuss with you quickly? Because exam is coming, right? Maybe you want a bit of a
Discuss.
change. I can't hear you, sorry.
Discuss.
All right, let's go fast. Okay. Now, in 12, you are oh. Oh no, this is okay. So why do they give you AR? Tell me.
4 more.
Great, very good. You have to talk about the mole. So 16 over 64, which is 1/4 mole for copper. And then 6 over 48. How many moles that?
1/8.
Right. So the same charge, the same electron. That's how you read in chemistry. The same charge is the same electron. The same electron gives you 1/4 mole of Cu and 1/8 mole of titanium. Do you know the answer?
No.
What does electron have to do with the charge? Do you have any idea? They tell you the charge of the copper ion, charge of the titanium. Why are we talking about the charge?
Right. It's like 2 plus, that means it's 2 electrons more than
Very
the
good.
full valence.
And obviously, to deposit copper, you go from Cu2 plus to Cu. If that makes sense? Right, that's how you deposit lah. So require 2 electrons, right? To deposit titanium, you are going to go from titanium, don't know how many plus lah, correct? Don't know how many plus. Here, 1 plus, 2 plus, 3 plus, 4 plus. It is true that titanium ions can assume all these pluses. You have not learned about that. They don't teach you in O level. They just tell you lah in the MCQ. Now, if this is 2 electron, does it make sense that this has to be 2 plus also?
No.
I'm sorry. Because of the 1/8, right? Good. Now, if it is a 1/8, shall this be more or less than 2 electron?
Less.
Okay. If you require less, for example, 1 electron. So this is 1 plus, right? When you require less electron, you get more mole of titanium or less mole for the same amount of electrons. Let's say I have a total of 1,000 electron, 1,000 charges lah. One guy used 2 electron, one guy used 1 electron. The guy who used 1 electron will
More.
result in more mole or less.
More.
Right. So this guy, more or less than 2 electron.
More.
And your choice should be 4 electron, not 3 electron, 4 plus, and therefore the answer is 4 plus. Do you understand?
Yeah.
This is still electrolysis, kind of-ish, maybe. Make sense?
Yeah.
All right, good. Now, if there is nothing else, we go to 13. This is purity. If I'm not mistaken, you talk about purity last question, right? Now, 50 gram impure, excess hydrochloric acid, blah, 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 6 dm cube. Now, regarding impure question, 50 gram is unreliable, as in, it will not give you the full thing, correct? But is this 6 dm cube reliable or not?
Reliable.
And reliable means you can get the mole. 6 dm cube, how many mole? Nick, how many mole? Keston, don't mute again. We're discussing very fast today. It's only
Okay, what's
you.
the amount of CO2?
Oh my goodness.
I need
Come
to tell
on,
you
that's a
what-
guess. It's a guess.
Like-
It's a guess. 24 dm cube, 1 mole.
32?
Correct. For any gas, and CO2 is a gas, 24 dm cube is automatically 1 mole.
It's 1
Right,
quarter.
remember? Yeah, so 1/4 mole. Okay, clear, yeah? Okay, so 1/4 mole. Do you think about the reaction? Do you have to think about the reaction?
Yeah.
Then please write down the reaction. There will be a practice for you. Please do so. Is it balanced? This is not thermal decomposition. Come on, it's not. They actually tell you that it is not thermal decomposition. Okay, that is HL, good. All right, and is it balanced? Oh yeah, wait. Is up, yeah, up. Looks balanced to me. Okay, looks balanced to me. Okay, 1, 2, 1, 1, 1 lah. Okay, good. Now, why does it matter?
No ratio.
So where do you want to go? So let me question this. Both direction is the same thing. You just want to go from unreliable to reliable, do a comparison, or reliable to unreliable, do a comparison. The same thing one. But you got to choose one lah. Which one?
Reliable to unreliable.
All right, so we take 1/4 mole as a start. There you go. That's your 1/4 mole. And we go to who? We go to the CaCO3, which is also 1/4 mole. Where do we go from 1/4 mole of carbon limestone? Where do we go?
CaCO3.
Yeah, which is the MR they tell you. Very nice, right? Why? Because,
65.
so how many grams?
2.
35 gram, am I correct?
Okay.
Okay,
Wait,
this is okay, this is reliable and this is unreliable. The answer is?
2%.
Yeah. Do you understand how to do this?
Yeah.
The reliable and the unreliable, people are psychologically better feeling using the reliable one. If you see an unreliable number, maybe you just leave it there until the end. You will know how to use them. Okay? Question 16. I'm curious. Can you do this yourself? Is 16 difficult for you or not?
Is it memorization or like what?
Is it possible for your mic to be closer, if that is possible?
Is it memorization?
It is not memorization. I would think you will want to do the redox number. Are you used to doing the redox number?
Like from the equation.
Yeah, do you want to think about the equation, a reaction? Yes, I do. Yes. So first of all, there must be a reaction. First of all, there must be a reaction. Maybe among these four, there are people who just don't react. Maybe. The way to do that, I feel, is always just better to write down the chemical formula first. As far as I can tell, Keston, you don't have any chemical formula problem. But would you please just practice that for exam? Just write down all the chemical numbers, chemical formula, I'm sorry. It's just easier to think that way. Please do so. Yes, what is that? If you don't know that, you better memorize. Okay, good, very good. KMNO4. And then ammonia is... You are correct. And then copper nitrate. And write down sodium hydroxide for you. Copper nitrate is incorrect. Very nice with the bracket. There you go. Okay, good. Now, let's talk about the reaction first lah. Is there anybody who will react with FeSO4? Do you have any idea? This is like you gotta search for your whole knowledge, you know. Maybe it's acid and base, maybe it's solubility, maybe it's displacement. Don't know. You have to search. Which one will react, you think? Oh, that's tough. Kind of tough, I guess. But it's doable. Yeah, it's doable.
It's not just all new.
I better wear my headset, okay? Wait, coming. Okay.
You're saying,
Is it not just all of it?
okay, this is important to talk about. So tell me, what is the reaction between KMNO4 and FeSO4?
Nothing.
Correct. There's nothing. And therefore, I don't think there's a redox reaction because I don't think there is a reaction. I don't think there will be. So, okay, let's cancel A for that reason first. Maybe you're right, maybe you're wrong. Who else? Are you saying that nobody will react? Uh-oh. Is that what you're saying?
You know, everything like except KMNO4.
You mean KMNO4 will react or will not react? I'm sorry, which
Will
one?
not, will not.
Oh, okay. I'll test you copper nitrate. What would be the reaction of copper nitrate with FeSO4, you think?
Oh, wait. Nothing also, right? Because it's acid.
Nothing also. I think it's both equals last still, right? Fe nitrate is equals, CuSO4 is equal. So let's cancel C for now. Okay, nice, no reaction. Ammonia and sodium hydroxide. What do you think? What is the reaction here?
Acid and base.
Which one is acid and base? Which one?
NaOH.
NaOH is base. I agree. Where's the acid?
Like, iron sulfate.
Iron sulfate is not acid. You? No? Don't you think? Iron sulfate is not acid?
Then what is it?
No? No? Yes? No? No? No, it's not. It's not. Hello. Oh, okay. I've never taught you acid and base. Now that's a salt, right? A positive ion with a negative ion, which doesn't seem to be any Hs plus or metal hydroxide. So they don't seem to be both acid and base. So no, I don't think it's acid and base. The reaction will probably be we call it precipitation because FeOH precipitates, right, into a solid. I think that would be the reaction. This one also This one will be in aqueous solution is NH4OH. So the likely result is actually the same thing. Precipitation is something you learn close with acid and base, but it's not acid and base reaction. Is this okay so far?
Yeah.
Are they redox? Are precipitation redox? In fact, are acid and base reaction redox?
No.
You are correct. They are both not redox. So we have a problem. Everything is wrong. Now, let's talk about acidified potassium manganate. I'm very happy that you remember this guy. What is this guy mentioned as usually? This guy is something. This guy is a
Oxidizing.
special variant. It's an oxidizing agent, a very strong oxidizing agent. Well, a nice fit to our context redox reaction. Perhaps this acidified potassium manganate can oxidize somebody, maybe. Is there anybody oxidizable in the iron 2 sulfate? Maybe.
The iron.
It can be iron 3 plus. That's your best guess right now, isn't it? A would be your best guess. The rest doesn't seem to fit. Make sense?
Yeah.
All right. Good questions. Let's continue. Wait a minute. Wait, Keston, how come your revision paper includes the last part of OChem? So I thought that's not part of the exam.
It's until like alkanes.
Yeah, this is like the super end part of OChem. You know this, right? You got to talk about polymerization and you got to talk about the two different polymerization. You do understand what's addition and condensation polymerization? If you don't, I can remind you.
I know it's addition.
Yep. You know what's addition, right? The double bond, right? The double bond one can, open up and, hold hands. The condensation one is just the esterification. And the new guy, the amide bond. My point is that's nowhere near alkane. Alkane is like so at the start, and this is so at the end. Did that make sense?
Yeah.
If you really want the differences, the condensation will eject a water molecule, a small molecule. That's one. Okay, condensation can happen. You don't need to talk about this, right? You don't need to. Really, you don't need to. Not gonna happen at all. Even the addition and polymerization, they cannot ask right now because they haven't talked about polymerization, only addition. right? Addition reaction does exist in alkene, and I guess that's about it. It's better for you to revise cracking. Cracking will almost certainly be asked.
Or like hydrolysis.
Hydrolysis simply means you are taking water out lah. Now, is there hydrolysis between alkane and alkene, you think?
Wait, no.
Yeah, I don't think so. But hydrolysis is the same thing as condensation for your purpose lah. So not yet. Once we get to alcohol, we'll talk about hydrolysis. If you talk about hydrogenation, substitution, cracking, that's the same question.
Oops.
Come on, ask harder questions, ask more questions.
The thing isn't loading.
Yeah, a bit slow, I know. Sometimes this happens with Jamboard. Okay, I got it. Oh, it's very slow, isn't it? Oh, oh my goodness, that's just so slow, isn't it? Okay, you know what? Let's not waste time. Sometimes explain why the enthalpy change. Right. Let me confirm that you did talk about isomers like in alkene, correct? Yeah. You did. Okay, good. Now the enthalpy change of combustion for two isomers are different because each isomers have a slightly different bond. Did that make sense?
Yeah.
Does that make sense? Okay, and that's basically the explanation.
But like,
Okay,
how do you
one
say
one
more?
isomer will have a slightly different bond than the other isomer. Ta-da!
Well,
If that makes some sense. Is there a continuation from before? Just checking.
It's like they
Is
give
this a
ethanol
is this
and
an
the isomer.
example?
Yeah,
For
just
example, do they give you the isomer?
Yeah.
Okay. Just tell me the chemical formula. I'm going to draw for you.
Ethanol.
Okay, ethanol, which is C2H5OH, right? I'm going to draw the isomer first, right? So, correct? OH is there, right? Now, how can this be an isomer, right? So, do they tell you the other isomer?
They put the O in between the C.
Correct. So it is no longer ethanol, by the way, right? It is no longer ethanol. This is called a ketone. Similar to your name, right? No. Okay, please check first that this is definitely C2H6O. This is also C2H6O. Just checking, and that's why they are isomers.
Yeah.
This one is alcohol. And this one is what they call ketone. And ketone is something that you learn only in JC. And they just put it there because that's the definition of isomer. Now you can focus on the difference of the bond. Okay. Explain one. No. Because, okay, breaking bond or forming bond here. The issue is breaking bond or forming bond.
Forming.
No, the forming of the bond both become CO2 and H2O, correct?
Oh, yeah.
Both become. The bond formation should be exactly the same. Make sense or not?
Yeah.
But the bond breaking is the difference, right? Make sense?
Yeah.
So which bonds are different? Which bond?
OH.
And who? And who?
Oh, there's one more CO.
Okay, I'm gonna do this. Okay, no. Now I'm gonna do this. 1, 2, 3, 4, 5. 5CH. Make sense? 5CH. Correct?
Yeah.
1, 2, 3, 4, 5. Okay, let's continue. Then 1CC, right? There. Okay. And then 1CO. There. Done. And then 1OH. Okay, done? Can
Yeah.
ya? Now compare with how many? How many CHs?
5. Wait, no, 6.
6. Good. Now you already have a difference, right? Okay. Okay. Easier to do it that way, like okay. See 5 CHs. And then what else?
2 CO.
2CO. Now what is the difference? Okay, I'm gonna just scratch it for you. Spread 1 CH difference here. 1 CO difference here versus there. That's the difference. 1 CC 1 OH versus 1 CH 1 CO. If you answer in this detail, there is no way you don't get the 2 marks. Do you understand?
Yeah.
So you answer bond formation, bond breaking. Bond formation is not different. Bond breaking is different. This guy compared to that guy. Ta-da! I know. Okay. Oh, you already have another one. Sorry. Okay, this looks like an electrolysis question, yeah? All right, okay, I can understand. Oh my goodness, okay. Tell you what, could you just send to my WhatsApp? I think it's just faster for you. Okay, sorry to make you go through all
Yeah.
this. Just send to WhatsApp. I'll copy it for you. Tell me when you have sent it, so that I can immediately put it in. Nothing sent yet.
And
Okay, I got something. All right, I'm gonna put it in. Thank you. Hopefully this is faster on my side. If not, I can still read, so that's not bad. Sorry, I have problem. Then we have to prepare for the Jamboard disappearing, right? Okay, gotta do a transition at June lah, when we have some time. Are you familiar with the OneNote from Microsoft?
no,
But it's okay. We'll probably do that during June lah, after the exam.
okay.
Okay, I'm reading everything, blah, 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 and I'm okay. So what's your question?
I,
Oh, you didn't give me the A. Okay. Yeah, maybe you need to, yeah, maybe. Hmm. If I see the pattern, yeah, yeah, there you go. I think I saw the mistake. Okay, do you see that? Do you see the problem?
here's the 20 time minute one.
Yeah, the 10 to 20 and 20 to 30. So I think the 20 should be the problem, no? Because the plus are not very consistent. Okay,
But why does it need to be consistent?
right. Think about it. What is electrolysis? I already teach you like back and forth, up and down. It's about electron forcing things to happen, correct?
Yeah.
Is the flow of the electron constant as far as you can tell?
Oh, yeah.
If the flow is electron constant, blah, 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 the reaction is constant, blah, blah, blah. So, and that should, if you want, you can put it as part of your reasoning, of course, right? Okay, good question. And good. I still really like to talk about it.
Then for the general pattern, did you say plus like around 0.4 or just general increase?
I'm sorry, which one again? Sorry.
Or general pattern?
A general pattern is around plus 0.4, average 0.4 something lah.
Then you can just say it generally increasing.
No, because all are increasing lah. Should you do that? Let me think. Yeah, I think you should say the average 0.4 something, because obviously the 10 to 20, 20 to 30. You gotta spot, right? You gotta see the general trend first, and there's nothing wrong with saying that it should be around 0.4 something. Nothing wrong. Not like they will re-ask this, but I think saying 0.4 something is nothing wrong because you're reading the data. You're using the data. And that is what they expect you to do in these kind of questions. Why else would they give you a data? If that makes some sense.
Yeah.
Don't be afraid to use the data. I guess it's alkane, yeah. So I guess this will be part of your exam, I guess. That makes sense. What's your question?
How do you explain?
Again, what is isomer? Here's the Here's the informal. Sorry, this is the best definition of isomer I can give you, right? Chemical formula the same, chemical structure different. Make sense or not? That's what
Yeah.
isomer is. Formula the same, structure different. So that's how you check. I mean, the structure is different, so you don't have to check that. What do you have to check?
Chemical formula.
Go and check. That will be like super apparent, right? You can immediately answer, oh, this guy, oh, that guy. Very easy.
Like, how do you explain it?
Exactly what I said. Like look, write down the chemical formula of product 2 and product 1 first. You gotta do some counting, right? Easy stuff.
C6H14.
Write down. Hexane is that, I agree. Product 2 is that. How about product 1? Unless you count, you don't be so sure. You better count your product 1. Okay, good. And product 2, just to confirm.
It's not isomer.
So how do you explain? Well, product 2 is an isomer because, product 1 is not an isomer because. Clear, right?
Yeah.
2 marks should be good. That logic is definitely what you will be using all the time. So good to know.
Checkpoint.
I'm sorry, what you think? Sorry, what was you saying?
Need to make new Jamboard.
Oh, yes, please. Tell me when you're done. I will go in. Okay, share with me.
I sent you.
Jamboard. Okay, I'm in. Caston, any problem so far? Anything
Anything from homework?
good thing? All right, got a new one. Okay. Right. So is this somehow electrolysis or not? What do you think?
Honestly,
Okay. What does an electrolysis need traditionally? What do you think?
electrode,
Okay, we have the electrodes, two electrodes here, right? One and then two, right? What else do electrolysis need?
electrolyte.
Is there an electrolyte here?
Yeah,
And does that answer your question?
no, but
The electrolyte has to be aqueous, right? If the electrolyte is not aqueous,
we're
how can
talking
it
about
conduct electricity?
the distilled water.
Distilled water. Why distilled water? Because normal water has a contamination of ions. Distilled water removes all the ions. Does your teacher talk about this? Basically, distilled water is pure water. Sorry. Basically, that's what it means. Pure water, because you remove all the ions. Like, am I making any sense?
I thought the question asking why cannot just put the aqueous? Why need to put water?
Uh, because wait, what? Sorry.
Why do
The
you need
electrolyte is the CuCrO4, right? Correct.
one?
Sorry, kind of, right? There's aqueous copper chromate, right?
Yeah.
The aqueousness needs to be if the filler paper is not moistened once you drop the drop here, how can the drop expand without drying out, if that makes sense?
So it's just for the ions to move.
Yeah, because the ions needs water to and conduct electricity, more important. Makes sense, yeah?
Yeah.
All right, we have a new one. See? Wait, what's your problem?
Isn't it like just all of it?
Ah, really? Ah, okay. Read the question one more time. Which equations are?
Oh.
Okay. Okay. Which one is wrong? Tell me.
Uh,
Second one. Very good. This question talks about the fractionating lah of the what do you call it? The natural oil, is it?
yeah.
Um, I guess the simple answer is because I mean, one is C3 and one is C4, right? That one you know, and therefore their boiling point is very similar because you know the length of the C chain is very similar. If that makes some sense. Fractionating column separation depends on their boiling points lah. Similar length, I guess you can say that.
It's polymerization.
I'm sorry, you're saying?
It's polymerization in like alkane.
No, polymerization only happens with alkene, the addition one, and ester bonds. Ester bond requires alcohol, carboxylic acid, yada yada. Definitely not alkene. You got to talk about substitution by UV though. So, I mean, just revise that. Okay, let's see. I'll make it bigger. Your question is A, is it?
Yeah.
No, he is giving you like super big hint, right? Use reduction. So I guess there's a redox here lah. Remember, if there's a reduction, there must be an oxidation, man. Using that clue, the first thing that you want to do is what is it?
It's really
I'm sorry, what?
Find which one gets reduced.
By finding out the redox numbers, right? So go and analyze the redox numbers, please. Correct, correct. Minus 2. That'll be a +4. Correct, correct. Just like that, you know who is being reduced and oxidized, I guess, yeah? Does this help you in any way? Does this actually help? Okay. If Si is reduced and carbon is oxidized, does that tell you about the, reactivity series, basically? Does that tell you? Yes or no? This is important. Yes or no?
I don't know.
I can't hear you. Tell me again.
I don't know.
Reactivity series, okay? You do have to think about that because that's where all the reactivity is analyzed, right? And the way I teach you reactivity series, that there's a mirror image. This is more complete and better than what the O levels are trying to teach you, right? Now, the carbon is from 0 to plus. Carbon 0 is on top or on the bottom?
Bottom.
No, carbon 0 is at the top. Carbon positive, well, in this case, 2 plus, it can be 4 plus, whatever. The point is, the positives are at the bottom. How do we know? Well, for example, sodium is here, and sodium plus is there. Very unhappy, very reactive, very happy, very stable. Am I making any sense, right?
Yeah.
The carbon is dropping down. Now, this is very important. I tell you, dropping down feels easy, easier. Easier than what? For example, aluminium. Where is aluminium? Where is aluminium?
Below carbon.
No, above carbon, below carbon plus. Make sense or not? It's both above and below, depending on we are talking about the aluminium or the aluminium 3 plus. Am I making any sense?
Yeah.
Now, your aluminum oxide, which one is it? Aluminum oxide is Al or Al3 plus? Ooh, you hesitated. Oh, not good. Which one?
2 plus.
Yes, correct. And that means the aluminium of aluminum oxide is not aluminium, it's aluminum 3 plus, and it means that it is very happy, right? It's very happy. To get him out to become aluminium is what you want, is what I want. It is not what he wants. Do you understand? He does
Yeah.
not want it. We want it. We like aluminium. We don't care about aluminum oxide. Okay. Now, this is where the dropping down and climbing up is very useful. C drops down is easy, is automatic, it gives energy, it's exothermic. Dropping down is exothermic basically, and jumping up, you guessed it, is endothermic, requires energy. Understand?
Mm.
How can C jump down, aluminum 3 plus jump up? Cannot, what? Obvious from the reactivity series. Understand?
Yeah.
That's the relative reactivity of carbon and aluminium. Now, silicon. Carbon, jump down. Silicon, jump up or jump down?
Up.
Correct. How do you know? Well, I mean, from plus to zero, lah, right? Zero is always here. So we don't know where silicon is, but silicon must be there, and silicon 4 plus must be there. Never mind the fact that this is non-metal. Who cares? Okay, whatever. The fact that silicon 4 plus can be forced to jump up means that it is definitely like that in the reactivity series. It will not be a higher jump than carbon jump down. It will be a smaller jump up because exo must be bigger than endo for the reaction to happen. Am I making any sense so far?
Yeah.
This will give you the answer already, look. Tell me if this is not enough help. This is like a basic, very important knowledge to know lah. Right? With this, you can answer a lot of questions.
How do you know which one is more between like silicon and aluminium?
I don't know, but I know that aluminium is above carbon. I at least know that because they asked me to memorize. Okay? They do ask me lah. So I don't analyze aluminum and silicon. I analyze carbon and silicon because that's what they give me. And then, well, I know aluminum and carbon, so I know aluminum and silicon. If that makes some sense.
Cool.
Aluminum is memorized in relative to carbon. You have to memorize it. They will assume that you know. Okay, check it out. They have a reversible reaction. Just to confirm that you do talk about reversible reaction in your exam.
I think.
You think, yeah? Okay, all right. Okay, so and for some reason you now learn this new reaction in stage 1. You have never seen this before. The second stage, however, you do know that from the Haber process. Okay, so the first stage is to take the hydrogen, right? Okay, good. Oh, this is the first time you see alkane react with steam, isn't it? So it is totally new to you. Fair enough, it's totally new. Right. Okay, now they have problem with question A.
Yeah.
Okay, now cannot be. You gotta read. They give you a lot of knowledge. This is a reading comprehension question. It is not a mistake that stage 1 you have never seen before. They are testing you. How? By giving you the relevant information. Okay. They even very kindly give you the condition for stage 2. By right, stage 2, you memorize the conditions and everything, but they just give you, including the delta H. Temperature. Did they tell you anything about temperature?
Yeah.
So what's the first reason?
I thought higher temperature means faster reaction.
Maintain the temperature. Maintain. Maintain. Higher temperature also means you have to maintain it. You have to heat it up, right? Heat will be lost. You learn physics, right? Heat up to 800 degree, it will be lost much faster than if you heat it up to 840, 450 kind of ish. Maybe you learn that. Okay, so what's the first reason?
It's that lower temperature.
Yeah, higher temperature, lower temperature. What is the second reason? It's in front of you. They do give you the relevant information. They do. I'm trying my best not to spoil it for you. Is it the pressure, you think? Does the pressure have anything to do with the temperature?
It's like bond forming.
What do you mean by bond forming, and what do you mean by that?
Because stage
Yes,
2 no
yes.
need to break bonds.
H.
Stage 2 no need to break bonds to form ammonia.
Okay, not correct. No. Every reaction will involve some sort of bond breaking and bond forming. How do we know? It's quite obvious when you draw. There's N, and then H times 3, lah, right? There's that, and then NH3 is 1, 2, 3, and H, and then times 2. Is it obvious to you in stage 2, you gotta break this bond and reform another 6 new bonds? Make sense?
Yeah.
There is a bond breaking and bond forming in every reaction. There are no exceptions, by the way. Maybe the exception is decomposition, because actually, no, there is also bond breaking and bond forming there. Right? Another reason. Is it the pressure? What do you think?
No.
Is it the catalyst?
No.
It's the temperature. All right, great. So what else is given?
Delta H.
What? Delta H. Is the delta H somehow helping you or not helping you maintain the temperature? Maybe. What do you think about delta H?
I forgot what it means.
Okay. First thing first, the minus and the positive. Do you have some guesses of what that means?
Endothermic, exothermic.
Which one is exo and which one is?
Endo is negative.
I'm sorry, which one? Sorry?
Endo is negative.
No, exo is negative.
Oh.
This is exo and this is endo. At this point, you memorize that first, okay? You gotta memorize that. Now, minus 92 exo means you gotta read it as, oh, it gives off 92 to the surrounding. Oh, positive 210. You gotta read that as it requires 210 from the surrounding or the environment. Making sense so far?
Yeah.
Does that have any relevance to, maintaining temperature?
Yeah.
Very good. Tell me what it is.
Like stage 2 it gives off energy. Then stage 1 it takes the energy.
so sorry, my connection is disconnected. Can you hear me?
Yeah.
Okay, sorry, yeah, my connection will be bad for a while. Okay, sorry, yeah, I was asking you what's the relevance, right? What do you think is the relevance?
It's like one takes in energy, one gives out energy.
So which one's easier to maintain?
Stage 2.
Sorry, which one's easier to maintain? Which one? The first one. The
The
first
second
easier.
one.
The second one. The second one is easier because this one also contributes. Easier to maintain. The first one, no, not really. Now let me ask you, let me change the question. Let's say the first one is minus 210. The second one is minus 92. I only change the sign from positive to negative. Understand? Which one's easier to maintain you?
First one.
What do you think?
Do you need to consider temperature? Hmm?
Sorry about the bad connection. Can you hear me now? Sorry, yeah.
Yeah.
Yeah, sorry, yeah. I was disconnected for a long time. Right. Hey, right. Regarding the negative 210 and negative 92, which one is easier to maintain temperature?
Then
Good, because it gives us more, lah, right? You gotta do the more thing, but I think the more is the same. Guess leaving your answer for B, right?
Hmm?
Wait, what?
this one's like the third question.
The third question? Oh, okay. So we don't need to talk about B, correct? This is C, is it? Okay. So gas living reactor. So I guess that's the second reactor, stage 2, lah, right? That's stage 2.
Hmm.
Contains unreactor 15%. Yeah, correct. Correct. By volume. Oh dear. So your ammonia chapter is not very strong, yeah, I'm guessing. This is standard lah. This is standard. So why would you want to, feed back N2 and H2 back to the reactor?
It's so that you can get more NH3 without like adding
Correct,
on
correct.
more.
Raw
Like,
material,
I don't
precisely.
know what's the second one.
Right. I see what you right. Let me think for a while. Please ask another question.
Part B.
Part B, right. Okay, so what's the waste gas here? Who is the waste gas? If you can accept, the definition of waste here are the gases that are not being used further, right? So I burn them. So who are the gases which are not being used further?
CO.
Correct. CO. Can you burn CO? Just checking.
No.
Yes, you can. CO plus O2 will become CO2, and that will be exothermic also, if that makes some sense. CO is produced, you learn how CO is produced by reacting in the absence or of enough oxygen. So you don't burn completely. So that means you can burn them again if you give him enough oxygen. Make sense?
Yeah.
Is there any other waste gases that we are talking about here?
Mm.
This assume there is only one, yeah, I guess. Now, why would I say that there's another one? Because this is a reversible reaction, and therefore the CH4 should also be, be present. Technically, you should fit them back in. So maybe we don't call it a waste gas. You can also burn methane. Make sense? Right? But you don't want to burn it. Maybe you want to just feed it back to the whatever reactor. So why is it important to burn CO?
Yeah. Carbon dioxide.
To produce carbon dioxide is probably not a benefit, right? Probably not, again. But CO from the pollution chapter, at least you learn that CO can be bad, right? So do you remember why CO can be bad?
Like affects the body. Something like the bloodstream.
Yeah, it kills people. Let's just say it kills people. Yeah, and you do not want to release it to the environment. I mean, what else are you going to do with a waste gas but to throw it off to the environment? Makes sense, right? It may not kill people, it'll kill birds, it'll kill a lot of other living things because of it being a poison. Correct or not?
Okay.
Okay. Now it's important why you burn it because it'll make your CO2 much less harmless, not much less harmful, sorry, much more harmless. Currently, my answer for the second reason is that if not, they become well, nitrogen is not a contaminant lah. You release it to the atmosphere. It's not a contaminant. That means if you don't use it, you have to throw it. I hope that makes some sense, right? Throwing nitrogen is not a problem. Throwing hydrogen, throwing hydrogen. No, not very sure. Okay, so the scrap steel to make new steel. Do you have any idea? Really? Right. So if you use blast furnace, you're not doing it from scrap steel. You're doing it from iron oxide lah, and that requires coal, I guess. That requires high temperature. That requires a lot of energy loh. Scrap steel, if you think about it, is scrap steel still, still iron, I guess. A little bit of iron oxide, but still a lot of iron lah. Cannot be that hard to change scrap iron to nicer iron, if that makes some sense.
Yeah.
Why is it important? Well, because it consumes less energy and because it removes waste lah. I guess those two things are very, very important. How very interesting. How very interesting. Oh, really? I didn't realize that your syllabus will talk about this. Right. Okay, right. Wow, but whatever I'm going to talk about feels like it's outside the syllabus, lah, so I apologize for a while, right? Now, would you expect that planting more trees is a long-term solution? You first, lah. Sorry, your mic. What is it? No. Okay. Well, now, why do you think it is not a long-term solution?
Giving things to expand.
Hey, what's going on here? How come the connection is so bad? Wait. Sorry, I cannot hear. All right. Can you hear me now? Hope this is better.
Yeah.
Okay, your sound is still so bad. Okay, sorry. Could you try that again? Why do you think planting tree is not a long-term solution?
What's the worst part?
Oh my goodness, it's so bad. I cannot hear you. Hang on. Don't think it's my connection. I'm gonna check for a while. I really cannot hear you talk just. I cannot hear it clearly. Yeah, I don't think my connection is the problem here right now. Okay, sorry, try again one more time.
Well,
Why planting the tree is not a solution?
because it will respire.
You type that. Yeah, your mic is still very bad.
Trees contribute less than use. So tree use more than contribute. How do we know? Because trees grow. What do I mean by that? When trees use CO2, he use CO2 to form organic molecules, C chains, right? So since the tree grow, it is evidence that C uses CO2 more than respiring, if that makes some sense.
Yeah.
Right. Yeah. Your mic is definitely very bad, or your connection is very bad. Yeah. Right. Okay. So although what you're saying reduces the effect, but I mean, tree is better than everything else. Tree does use CO2 more than giving off. So why it's not a long-term solution? The increased amount of CO2 is largely due to consumption, right? We need a lot of stuff lah. We need energy. We need to burn things. We need to do a lot of things that produce CO2 lah. Almost all things that we do require CO2, if that makes some sense. Planting tree is slow and the tree itself grows very slow. So the issue is rate. The planting of tree and the growing up of tree is going to be slower no matter what than our increase in consumption. How do we know this, or how do I know this? Yeah, because that's totally outside the syllabus, but it is true outside the syllabus. I apologize for that first lah. The usage, our consumption is just much more higher than whatever speed of trees you can grow and whatever not. Anyway, if you want to plant trees better, you got to plant trees which are more like a forest, which is very complicated. You cannot just plant trees, just one type of tree. It really doesn't work. The tree itself dies. That's biology instead of chemistry, totally out of the syllabus. Do you learn biology?
No.
So I apologize if I keep quoting things outside OChem syllabus. What else can I do? Okay. But that's why planting tree is just not, it's not because everything else, if you want to do planting trees right, it's just very slow, no matter what. But consumption increases by a lot more because I guess it's easier than planting trees. So it's not a long-term solution. It's just part of the solution. I'm not saying that it is not a solution. It is part of the solution. Okay. Basically, the main point of the solution should be the reduction of consumption or the reduction of CO2, even though the consumption increase. Again, totally outside the syllabus. I am guessing that this is the last part of the question. Am I correct?
Yeah.
So the last part of question tends to be the type who, test you on things, outside your comfort zone. Let it not bother you. Just take in what I'm saying. It will be correct, but don't think about it too much lah. you need to talk about the other one better. Like question A, B, and C, I will argue is just much more reliable, right? Even the scrap steel also more reliable. Don't think about the planting tree too much. Any other question? We are at 9 o'clock.
No.
What do you think? Are you more prepared for your exam?
Yeah.
How much do you practice by yourself? Because I don't give you homework, right? I haven't thought about the need lah. How much do you practice by yourself?
Recently, not much.
Tell me why.
Exam.
Tell me why.
Exam.
Other exams, fair. There are other exams. Now, in chemistry, make a prediction. How many % you will get?
I don't know.
Make a guess. Of course, I will ask you to predict again after the exam. That will be better. Right now, I'm asking you to predict because I want to know how prepared you think you are. So how prepared you think you are?
B.
B. Give me a percent. 65, 70.
4.
Before, you mean? So
Yeah.
that's below 65. 60 to 65, something like that.
Yeah.
Okay, let's say prediction before exam. 60 to 65%. After exam, I'll ask you to predict again. Next week, I'll see you. You have done the exam. All the best, Keston, and I will see you